Okay, so section 6.1. So for the first few sections, we're going to talk about vectors. And then the next section after that, we're going to do things that's similar to vector, but not quite. Okay, so I assume that you have not seen vectors before, so we're going to start from the very beginning. Vectors are arrows because there is an arrow that points on there. And so vectors, you have to remember there are two things. It has magnitude and direction. Okay, magnitude and direction. Every vector has magnitude and direction. How do you figure out what this vector is? Well, this vector has two very important points. This point that has the where it starts, this is called the initial point. And where the vector is pointing, this is called the terminal point. Okay, initial point and terminal point. Now, if you want to figure out what this vector is, then you're going to take the terminal point and then you subtract the initial point. And this is kind of the important part. Any kind of vector that has the same final points are equivalent. Okay, and I'll show you what that actually means. Let's go ahead and find this vector first. So, in this vector, what is the coordinate of the initial point? What is the coordinate on this coordinate plane? 1, 2, correct. And we write 1, 2 like with parentheses, right? Because we're just talking about that one point, 1, 2. What is the terminal point, or where is the terminal point? 4, 6. Okay, in order to find the vector, we are going to take the terminal point and minus the initial point. So this is going to be 4, 6 minus 1, 2. Okay, and this very simple math, we're going to get 3, 4. When we get 3, 4, this is not another point. We're going to talk about this as a vector. And so when we talk about a vector, we write it in this way. The triangle looking bracket, that tells me this is a vector and not a point in space. But remember I said that vectors have magnitude and direction. 3, 4 is just a number. How does that create a distance? Right? Because 3, 4 is kind of like a place in space, right? 3, 4 is right here. That's a dot. That's not a vector. Vector has to have a length with a pointing arrow, right? So what does that actually mean? If you have any vector that's in this form with a triangular bracket, that is a vector, and the vector, this is going to be the terminal side, and the initial side is always from 0, 0. So this is actually my vector. 3, 4 is my final form of the vector. That vector is always pointing from 0, 0. Okay, this form has a name. So if you look all the way down to the bottom, the form with this bracket thing, this is called a component form. And it might be nice if you make a list of all the vocabs you need for this chapter, because there's a ton of things. So things like, I would say, write this in component form, or write this in some other form, trig form, or something like that. And you got to know what I'm talking about. So, yes. And, all right. Here is kind of the tricky part, or the confusing part. Any vector that has the same magnitude means length, same direction, that means the arrow's pointing at the same direction, is exactly the same vector. So let me ask you a question. Is this the same vector as the other two? Yes. Why? Pointing in the same direction and same length. Okay. What about this vector? No. Why not? same length, right? Not pointing in the same direction. So not the same vector. So vector is basically, I can move it anywhere in space if I want, as long as it's the same length and same direction. So it's kind of weird, because usually in geometry, that, whatever it is, if it stays there, that's the same thing. But this time, I can move it anywhere around in space. So it gets a little confusing, and we need it for much, much later things. Anyways, let's do an example. Show that the arrow from R to S is the same or equivalent to the arrow from P to Q. Okay, so R is -4, 2. And S is -1, 6. All right, I'm gonna have you talk to your partner. Which direction will this vector point? To R or to S? All right, let's vote. How many people say it's gonna point towards R? How many people say it points towards S? Yes, but why?
Because it says on there.
What does it say?
It's going to S.
From to. Yes, very good. So we're going to point towards S.
I thought it was a trick question.
Okay, now if you look at this, RS, they have this arrow, right? The arrow is pointing towards S. So, okay, according to how I find the component form of the vector, am I going to take R minus S or S minus R? Ooh, okay, let's vote. How many people say R minus S? How many people say S minus R? Correct, S minus R, because terminal minus initial. Okay, so -1, 6 minus -4, 2. So -1 minus -4, that is 3. And then 6 minus 2 is 4. Remember to write this in component form. So 3, 4. How do I check to see if it's exactly the same vector as PQ?
Check the vector.
How do I check the vector? Huh?
Like use 3 minus 2.
Okay, so find the component form of PQ. Yes, so find the component form of PQ. If they're exactly the same, then they're exactly the same vector, even though it's somewhere else in space. Yes, so Q minus P. All right, what is the component form of PQ? Yeah, 3, 4, so they're exactly the same vector, right? Okay, so now a few things about the way you write these vectors. First, if you're gonna talk about the vector, you gotta put an arrow on it. So if you're gonna talk about, let's say, the vector U, then you can't just write it like that. You have to put an arrow. Kind of like geometry, when you're talking about a line, you do this. If you're talking about a line segment, you do that. So same thing here. If you're gonna talk about a vector, make sure you put an arrow on only one side. Now another thing that's going to happen is when you look at your book is not always going to have an arrow. It sometimes does this, like it has a bold U like this. That means vector. They don't put an arrow on it, but they actually mean vector. So if it's bold, it's a vector. But when you write it, don't bold your letter. I cannot tell if you're bolding it or you're just tracing it over. So you just always write a arrow over it. Good? Okay. Now let's try to find the magnitude. Remember, magnitude means the length of the vector. So this is really simple. We're going to just think about how we're going to find the length. So let's say that you have this vector PQ, where P is -3, 4. And Q is -5, 2. Oops. PQ, so we're going to point towards Q. Okay, the question is how long? How long is this vector? What can you do to figure out the length? Yeah?
Distance formula.
Distance formula. So how would you apply the distance formula? Do you remember the distance formula?
Square root.
Square root?
2 minus y1 squared plus x2 minus x1 squared.
Uh-huh. Okay.
Yeah, right.
Yes, that's right.
Okay.
Distance formula is really just the Pythagorean theorem. Did you guys know that? No, that's okay. We'll figure it out together later. Okay, so we can use distance formula. So now how do I apply to figure out the length of PQ? It has some points, right? -3, 4, and -5, 2. I can just plug those numbers in. So y minus y squared plus x minus x squared. And then square root the whole thing. Basically, a squared plus b squared equals c squared. Yeah? Okay, so 2 minus 4 squared plus -5 minus -3, so plus 3 squared. We get -2 squared, that's 4. And then -2 squared, so 4 and 4, this is square root 8, that is 2 root 2. What's another way? What if you can't remember the distance formula? How are you going to figure out the length? Okay, in this one, special triangle works. But how did you know it was a special triangle? How did you know it's 45? There was no angle. Oh, where's the right triangle? There's nothing. How do you make it? XY component. Tell me more.
You break the vector into two forms, one in the x-axis and one along the y-axis.
Yes, so here is my right triangle. And since this is a right triangle, this must follow the Pythagorean theorem. Right, this is 2, this is 2. This must be 2 root 2, like what Caleb was saying. But if it's not a special right triangle, you can always just use a squared plus b squared equals c squared. So very intuitive. We're just trying to figure out the distance. So there are two forms. If you're trying to find the magnitude, when they want you to find the magnitude of the vector, they're going to put absolute value looking bars, but they just mean magnitude. Okay, so when you see these absolute value looking bars, they're basically saying please find the magnitude. So there are two ways. If they give you two endpoints to this vector, then it's just the distance formula. I'm going to write x2 minus x1 instead, because we start with x instead of y, but it really doesn't matter which one you do. If they give it to you in the component form, the other end of it is just 0, 0. So we don't need the distance formula. It is just a squared plus b squared equals c squared, but a and b are these two components, so it's just the square root of a squared plus b squared. If you cannot remember these formulas, which I really don't want you to, you should just think about this vector. It's just 2 points. You're trying to figure out the distance, and that's it. All right, so let's go ahead and have you practice. Find the magnitude of RS. All right, the answer is square root 13. Good? All right, the next part. This is a little bit tricky. Magnitude. Magnitude is a scalar. Magnitude is just a number. And I tell you this because in the next two sections, it gets a little bit tricky. You need to know which one is going to create a scalar, which one is going to create a vector. And there, if you don't know it, you might end up writing something that makes no sense. So kind of keep in mind which one is going to give me a scalar, which one is going to give me a vector. Scalar. Do you remember what scalar means? Maybe not. We talked about it last year in the matrix chapter. Scalar just means number. So in matrix form and also in vector form, we don't really say a number. Well, we don't say constant or like coefficient. We call it scalar. Scalar just means a number. And so when we have a scalar k and we're trying to multiply to the vector u, all you're doing is you're taking the scalar and then you're multiplying it to every component of this vector. And so it becomes k u1 and then k u2, like that. So it's very simple. You're just multiplying the number to every component. Okay, let's go back a page. All right, next, we're going to add two vectors together. And I'm going to show you both ways, graphically and algebraically. When we add them together, adding things together is called a sum. But they're also going to say the word resultant. So if they say, find the resultant of these two vectors, they mean find the sum of these two vectors. Let's say that the vectors are u and v, and they have these components. What you're going to do is just add the x parts together and then the y parts together. And that's it. So adding vectors is very easy. Just add the x parts and then add the y parts. Okay, so for example, we're going to do these algebraically first, and then I'm going to show you graphically. First, we're going to do u plus v. So u is -1, 3, and v is 4, 7. And so we're going to add the x components together. So -1 plus 4 is 3. And then the y component is 3 plus 7, so that is 10. So the resultant vector is 3, 10. Okay, you're going to do this one. 2u minus v. 2 is a scalar that's multiplied to vector v. Okay, what you guys get for the vector 2u minus v? Yeah, -6, -1. All right, so that's pretty easy. Now let me show you how to do this graphically. This is a little bit tricky. This took me like 3 years to figure out how to do. Okay, it's not because it's hard. It was because I didn't understand what was going on and I never asked. I was just like, oh, I don't understand this. I'm going to read the book a few more times. I still don't understand. I don't want to ask my teacher. And then it continued. And then because my major was engineering, you had to do this all the time. And I was very confused all the time. And finally, I figure it out by reading it so many times, but I don't want that same thing to happen to you. So if you have any questions about how to do this, please ask me, because the first time you see it is like, what? Why am I doing this? And what exactly should I do? So please ask, okay? If you're confused, please ask. All right, there are two ways to add a vector. One is called the tail to head method. So let's say you have two vectors like this, u and v. Okay, the first method is called tail to head. Tail means the tail end of the vector, which is where you start, and the head is the arrow part. So what we're going to do is we're going to match the tail to the head. Okay, I think it might be a little hard for me to do it. Oh, let me see. Okay, so what I'm going to do is, let me see if I can do this. Okay, so I am, sorry. Okay. Okay, so we actually move it here and then draw a line from the tail to the head. So this is u plus v. This is the first method. It's called the tail to head method. The second method is similar. It's called the parallelogram method. So we're going to do the same thing, u and v. This one, we're not going to move anything. We're going to draw a parallelogram. And basically, you have two lines like this. You just need to fill in the other two parts so that it becomes a parallelogram. So like that. And this one, the resultant vector, you see how in the beginning, your two vectors are, the tails are pointing together? You're going to start from here And then draw a straight diagonal to the other side. And this is u plus v. Again, please make sure you're pointing in the right direction. The arrow is important. Okay, we're going to do an actual practice. So this one down here. We're adding u plus v. We know the answer is 310. We just need to verify graphically it will be 310. So I'm going to draw some axis here. I'm going to draw a little low because if it's 310, then it's quite long. Okay, first I'm going to draw my u vector. U vector is -1, 3. V vector is 4, 7. Okay, depending on which method you want to use, we need to add the two vectors together. So u plus v. If we are going to use the first method, the tail to head method, then we need to move v vector. So since you're in notability, it's easy for you to move. You would just move this v vector so that the tail matches with the head of the first one. So it moves up like this. Okay? And then you draw a straight line from the tail of the first one to the head of the second one. And the place that your resultant vector is pointing should be 310, if you did it correctly. Are you guys with me, kind of? Yeah? Okay, so let's assume you physically did move it, like here. So then the resultant vector is this one, and let's see if it's 310. It is 3. Let's see if it's 10. Oh, I drew my vector wrong. Yes, I think that's right. Yeah, that's right. Okay, so 310. That's the first method. If you try to do it with the parallelogram method, it's the same idea, except you're going to have to draw a parallelogram. And here's my trick on how to draw a parallelogram. I'm going to assume the head of u is 0, 0. And I'm going to graph v from there. V is 4, 7. So I'm going to count 4, 7 from here. So 4, 7. And then I draw my vector, and then draw my parallelogram, and then draw the final one. Are you guys with me? Kind of? Okay, so I would say 4, 1, 2, 3, 4, and then up 7, 1, 2, 3, 4, 5, 6, 7. All right, so this is my parallelogram. So then I know my final one, I'm going to do this in green, is this one. Yes?
Just use the other method?
You can use any method you want.
Do you need to know both methods, or can you just like?
Okay, so basically this is where you're going to learn this if you're in AP Physics. You're going to do this a lot. But if you're not planning to take any kind of engineering kind of classes, probably you can just choose which one method you want to use. All right, let's go ahead and try 2u minus v. 2u minus v. Whoop. All right, we're going to start with u and v. U is -1, 3. V is 4, 7. Okay, the first thing we need to do is 2u. 2u. What does 2u mean? Yes, we know what number it is, but what does 2u actually mean? Yes, that's like algebraically, but what does it actually mean by 2u? The length doubles. So there are two of this vector. Okay, so 2u just means twice, so it's going to be this long, 2u. Minus v. Minus v, another way to think of minus v is the same as plus minus v. What does minus v actually mean? Can you guys help me? Can you point to where you think minus v is? Yes, this way. So minus just means the opposite, totally opposite direction, so that's 180 from where it should be. So the original v vector is 4, 7. Minus v is going to point towards negative 4, negative 7. Okay, so now go ahead and draw the vector, the resultant vector, whichever method you choose, whether you want to do tail to head or parallelogram. So let's assume you use the first method, the tail to head method. So what you're going to do is move this one to match up here. I can't really move this, so I'm going to try my best to draw this correctly. So this is 4, 7. So, okay, so the resultant vector is from the tail of the first one to the head of the second one. So that should be pointing towards negative 6, negative 1, if you did it correctly. We only have time to do very little of the next part, and then make sure you study for your test. That is tomorrow. All right, unit vector. What does the word unit mean? 1, like unit circle, right? 1, radius of 1. So unit vector is a way of making the magnitude of this vector 1. And the formula to create a unit vector is you take the vector and you divide by its magnitude. That will guarantee that this vector will only have a magnitude of 1. So let's look at this. You have, it says, find a unit vector in the direction of, this is kind of strange, direction of this vector. So remember, every vector has two things, magnitude and direction. So we want it to point towards negative 3, 2, but not be that long. We want it to be just 1 long. Okay, so we want to point in that direction, but just 1 long. So in order to find this this unit vector, we're going to take the vector and divide by its magnitude. Okay, this vector is negative 3, 2. How do you find the magnitude of this vector? Not the distance formula, we don't need it. Yeah, Pythagorean theorem. But because we only have 1 point, we don't have 2. Yeah. So we're going to just use the Pythagorean theorem. So square root of negative 3 squared plus 2 squared. So this is going to be negative 3, 2 over, this is 9 plus 4, so square root 13. So we have a vector divided by its magnitude. And magnitude, remember, is a scalar. So we can just multiply this in. So negative 3 over square root 13, comma 2 over square root 13. So this is a vector that points in that same exact direction, but it will only have a magnitude of 1. So if you try to use the Pythagorean theorem again, it should give you a magnitude of 1. Are you guys okay? Kind of? Questions? Yes?
Do we have to rationalize?
No.
Or
No. Pretty much, you've graduated from rationalizing. You don't need to rationalize anything. You just need to know how to do it if you need it. Okay, so let's look at what this means. Okay, vector v is negative 3, 2. That's this one. We want a unit vector that points in that direction. So we said the unit vector is negative 3 over square root 13, comma 2 over square root 13. I'm going to try to figure out what that number is and see if it's actually a vector that points in the same direction. So 3 divided by square root 13, this is negative 0.83. And then 2 over square root 13 is 0.55. So negative 0.8 negative 0.55 is about there. So it's a vector that points in the same exact direction, but that magnitude is just 1. Does that kind of make sense? Okay.